Hello everyone. Okay, so let's proceed to chapter 6. Chapter 6 is trusses and frames. No? Or trusses module natin nakalagay doon is trusses, frames, and machines, but we will focus our discussion sa analysis of trusses and frames. Okay, so sa chapter 6, alam na natin, chapter 5 I should say, we have discussed kung paano mag-solve ng support reactions. We have discussed yung mga different types of supports na ginagamit natin sa analysis ng structures. Okay? So, ngayon naman, we're going to analyze structures. Okay? And, of course, dapat alam natin kung paano mag-solve ng support reactions. Okay. So, let's start with our first topic, analysis of trusses. So, we're going to analyze plain trusses. No? We'll see if we can still discuss space trusses. But space trusses are normally discussed naman sa structural analysis, which is a higher engineering subject. No? Ayan. So, what is a truss? Let's try to define yung truss. Truss is a structure composed of straight members. So take note, straight members, these are the keywords, connected together with pin joints. Pin joints at their ends and loaded only at their joints. Okay, so take note, the connections between these straight members are pin or hinge. Parehas lang yan. And then they are loaded at the joints lang. So ang assumption natin is that the joints are pin connected and then the loads are applied on the joints. Okay? But of course in reality, yung mga nakikita natin na trusses normally sa roof trusses, they are welded, no? Welded siya, which means at the joint the members at the joint na pwedeng may moment doon. Okay? But to simplify our analysis, we're going to assume that all joints, kapag when we analyze trusses, all joints are pin connected. No? Okay? So, yung ibang connections sa trusses, bolted siya or riveted, no? Yung mga trusses na. But, sa mga bridges, sometimes, or ibang structures, combined yung ginagamit nilang connections. Pwedeng welded, pwedeng bolted, pwedeng riveted yung connection. So, pwedeng combined yun. Bolted tapos welded pa siya, or riveted tapos welded pa yung connection natin. Okay? So these are the assumptions that we're going to make. That the joints are pin connected and the loads are applied dun sa joint. No? So trusses are assumed to be of negligible weight, no, compared to the loads they carry. So if you compare yung loads carried by the trusses and the weight of the members, no, weight ng truss ay negligible siya. So masyadong maliit compared to the loads carried by the truss. No? And every member of a truss is a two-force member. So two-force member yung every member ng truss. So that is members acted upon by two equal and opposite forces directed along the member. So, okay? So, let's me illustrate that. Kung ito yung member ng truss, okay, two-force member siya. So, pwedeng tension na i-stretch yung truss member natin, or pwede na rin namang nako-compress yung truss member. So, yung members ng truss can be subjected to tension forces or compression forces. Okay? Ito. So, two-force member. So, truss analysis involves determining the external reactions. So, usually ito yung gagawin natin sa pagka-analyze ng truss. We're going to determine the reactions at the supports and determining the internal forces in each member dun sa truss. So, pwedeng tension, sabi ko kanina, pwedeng tension, pwedeng compression. Okay? Okay, so plane truss, a truss that lie in a single plane, which is used to support roofs and bridges. So makakita tayo ng trusses, ginagamit natin yan for roofs, roofing. That's usually the case in our country. So yung mga roofing natin are oftentimes supported by trusses. And bridges, so may mga bridges tayo na truss bridge. Okay. Simple truss, constructed from a base triangle, so base triangle, by adding two members at a time that meet at a new joint. Ayan. Ito yung simple truss. For example, mag-drawing na lang tayo. So meron tayong base triangle. Ito yun, triangle. And then, it is constructed by adding two members, no, at a time that meet at a new joint. So mag-add tayo ng dalawang member. Ayan yung truss natin. Dalawang member. Ganyan. So, by adding two members, so meron tayong base triangle, and by adding two members, we are going to form a simple truss. So, yan yung definition ng simple truss. Examples ng simple truss: Pratt truss, Warren, Howe, K-truss. Yan yung mga, usually ito, nakikita natin sa mga bridges. Ito, Pratt and Warren trusses sa bridges. Pati yung K-truss, no? Ito naman for roofing. Kita tayo sa roofing. Okay. Meron din tayong aside from simple truss, meron din compound truss, consists of two or more simple trusses. So combinations yan ng simple trusses. Meron pa tayong isa yung complex truss, but discuss yun sa structural analysis. Okay, so we deal with complex trusses and space trusses din sa structural analysis. Okay? So compound truss, you have this one for bridges naman ito, usually. Yung think truss meron din. Sa roofing means minsan sa mga mahabang mahaba yung length ng truss. So ginagamit sa mga gymnasiums, mga ganon. Okay. Think truss. Baltimore naman, mahabang bridges, Baltimore trusses natin. Okay, so yan, those are types of trusses. Okay, so importante, yung assumption natin is that yung joints are pin connected and the loads are applied at the joints. Okay, then we also have another topic here that is zero force members. We will go back to this topic kapag natapos natin yung isang method sa pag-analyze ng truss, which is the method of joints. No? Kasi para mas ma-appreciate natin itong topic na to. So we'll go back to this topic when we're done with method of joints. Okay? So because the principle dun sa method of joints will be applied dito sa pag-identify ng zero force members natin. Okay? So, let's proceed. So, meron tayong how many methods sa pag-analyze ng truss? We have method of joints, okay? Method of sections, and we also have the graphical method, which is hindi na masyadong ginagamit yung graphical method sa pag-analyze ng truss. Okay? Kung mapapansin nyo sa mga textbooks natin, sa mga books in statics of rigid bodies, and even structural analysis, wala na yung graphical method sa pag-analyze ng trusses. Okay, although meron din, that's another method to analyze truss. We will no longer discuss yung graphical method. We're going to discuss the two analytical methods, which is the method of joints and method of sections. Okay, so let's start with the method of joints. Yung method of joints natin. So how do we perform itong method of joints sa pag-analyze ng truss? So again, sa analysis ng truss, ang ginagawa natin usually, we solve for the external reactions. So dapat na-master na natin mag-solve ng reaction sa previous chapter. And then mag-isolve natin yung mga forces acting on each member dun sa truss natin. So, pwedeng yung member ay subjected to tension, force, or pwede rin compression. So, nako-compress yung member or nai-stretch siya or in-tension yung member. So, ganun lang ang gagawin natin sa pag-analyze ng truss. Okay? So, importante ito, no? Kasi sa design subjects ninyo, it is assumed na alam nyo na mag-analyze. So, sabi ko nga nung sa introduction natin sa subject na ito, we will be analyzing structures or forces, no, acting on structures. So, dapat na-master natin to because it's a prerequisite dun sa pag-design ng structure. Because the design of structures would be based on the forces acting on the structure. So, if the forces acting on the structure are yung magnitude niya ay malakas, of course, yung design natin, we would be designing the structure to resist yung mga forces acting on the structure. Okay? And dito sa trusses naman, so importante alam natin, ma-solve natin yung mga forces, bar forces, yung mga forces acting on each bar, no, so that we can design, no, para ma-resist niya yung forces that would be acting on the bar member, okay, or sa bawat member ng truss. No, kapag nagkamali tayo sa analysis, malakas yung forces acting on the bar, tapos maliit lang yung nilagay mong member, okay, nagkamali tayo, ang nasolve natin na force ay maliit lang, kaya yung nilagay natin na member ay maliit lang din, okay. So, pero in reality, sa totoo pala, malakas pala yung force acting on that particular member, then tendency is that mag-fail yung particular member, and worse would be mag-fail yung structure. No? So, ayun ang ayaw nating mangyari, mag-fail yung structure. Kung bridge yan, truss bridge, dumaan yung sasakyan, nagkamali ka ng computation sa pag-analyze ng structure natin, dumaan yung sasakyan, nag-fail yung structural member, nag-fail yung buong structure, nahulog yung mga sasakyang dumadaan sa bridge, naloko na, no? So, liable tayo sa dinesign natin na structure. Okay, so importante na alam natin mag-analyze ng structures. Okay, so method of joints. The method of joints is based on the fact that if the entire truss is in equilibrium, so ito yung principle behind this method. If the entire truss is in equilibrium, then each of its joints is also in equilibrium. So bawat joint, of course, it follows, no? Kapag yung buong truss ay in equilibrium, it follows that every joint is also in equilibrium. Okay, that's the basic, that's the fundamental principle here. So the free body diagram of each joint is used to obtain the member forces acting at the joint. Since the members of the plane truss are straight two force members lying on a single plane, each joint is subjected to a force system that is coplanar. Okay. And concurrent, so forces that lies on the same plane and at the same time concurrent. Kapag concurrent, nag-intersect, no? May intersection. Hence, we can use now the two conditions of equilibrium, which is the summation of all forces along x-axis should be equal to 0, and summation of forces along the vertical axis y is equal to 0. No? So we can use these two conditions of equilibrium to solve for the bar forces. Okay? So sa method of joints, from its name na method of joints, no, we go from one joint to another. So we start at a certain joint, then we puntahan natin lahat ng joints na para i-analyze, i-solve yung bawat force na sa bawat member ng truss. Okay? Okay, so let's solve an example na how to analyze trusses using method of joints. Alright, let's solve this problem. Determine the force in each member of the truss and state if the members are in tension or compression. So this was taken from the book of R.C. Hibbeler. So these are the answers. Answers so that we can check. By the way, I took this from sa module natin sa my exercises. Okay. Although may mga solved problems po doon, pero you study yung mga solved problems, isolve na lang natin yung mga nasa exercises na problems, no? Kasi some of you sa previous chapters, ano, sa mga exercises, some of you were asking how to solve yung mga, it's good, no? Kasi some of you are trying to solve yung sa exercises. But since some of you are asking about how to solve the exercises, mga ganon, let's just solve it dito sa dito sa ano natin, sa lecture video natin. Okay? So we are tasked to solve for the force in each member of this truss. So this is a simple truss, ano, using method of joints. And we are also required to state whether the member is in tension or compression. Okay, tension or compression. Okay? So first, anong kailangan natin gawin? Sa method of joints, we go from one joint to another. So you choose a joint, you know. But normally, isolve muna natin yung mga reactions. Support reactions, external reactions natin. So we have at joint A and joint B, meron tayong supports dito. So at joint A, ano yung support natin at joint A? This is a hinge yan or pin. We can assume any direction naman sa support reactions natin. But one way, kapag simple lang naman yung loading ng truss, by inspection, you can easily identify yung yung direction ng reaction, using Newton's third law. So if you try to analyze this truss, okay, these forces, these two forces would tend now to rotate or igaganon niya yung truss natin, pupush niya pa ganon yung truss natin, which means that itong members AE and ED, obviously, since pag ganon yung direction, obviously na-stretch yan, and yung reaction of course dyan, yung vertical reaction dyan is downward. So let's say this is R A Y. Now you can assume it to be upwards naman, but kapag mali yung assumption natin, then mag-negative lang yung result dun sa solution natin later on. So pag negative yung result, ibig sabihin mali yung assumption natin ng direction. So pero tama naman yung value or yung magnitude, okay? So let's see mamaya kung tama yung analysis natin. And meron ting horizontal reaction dito sa may joint A, so may support A, and direction of the forces are to the right, which means from Newton's third law, which means that the reaction dito sa the horizontal reaction dito sa may pin A, that means to the left siya, for the truss to be in equilibrium. Okay? And we'll see later on, tama yung assumption natin ng direction. And then, sa point or sa my point B, ang support natin sa point B ay this is roller support. So pag roller, perpendicular dun sa, perpendicular dun sa surface. Okay, sa contact surface. Let's say RB. Okay? Ayan. So first we need to solve for the reactions, pero hindi naman necessarily lahat ng problems ay kailangang i-solve yung reactions, but usually that's we normally do, no? Solve muna natin yung mga reactions, external reactions. Dito, you can analyze this truss without solving for the reactions. Okay, first. Sabihin ko mamaya. Pero ngayon, let's solve muna for the reactions. So to solve for RB, again, so you summate moment, considering the entire structure, you summate moments where two or more unknown forces are located. So saang banda yon? At joint A. So summation of moments at A is equal to 0. Okay. Clockwise moments, positive. So we have, ano yung mga may moments sa A? Siyempre, yung RB natin, it creates a counterclockwise moment. So minus RB times its moment arm about A is 2 meters. May moment din yung 600 Newton force, which creates a clockwise moment about A. So positive siya. So plus 600 times moment arm niya is 4 meters. Then may moment din of force yung 900 Newton force, which is clockwise, I should say. So plus 900 times moment arm is 2 meters. Okay? So that is equivalent now to 0. So we can now solve for RB using this equation. RB is 2,100 newtons. That's RB. And we can use the other two conditions of equilibrium to solve for the other two unknown support reactions. So we can summate forces along x-axis equals to 0. Forces to the right, positive. We have assumed RAX to be to the left. So RAX plus 900, okay, plus 600, and that is equal to 0. So RAX, tama yung assumption ng direction, ilipat natin yan, maging positive na yan, because RAX is negative in this part of the equation. So RAX is 1,500 newtons. And summation of forces along the vertical direction or vertical axis is equal to 0. Upward forces, positive. So lahat ng vertical forces, dalawa lang naman. We have RB and RAY. So RB is up, RAY is downwards. Assumption natin, of course. RAY minus, dapat yan, negative, plus RB, which is 2,100, equals 0. So again, tama yung assumption natin ng RAY. So RAY is also equal to 2,100 newtons. Ayan. So tapos na tayo dun sa reactions. Next. What's next? Next is now, you choose a joint. Okay? Joint. Pwede tayong mag-start. Hindi ka sa joint. Paano tayo pipili ng joint? So, pwede tayong pumili ng since sa method of joints, we can only use two equations or conditions of equilibrium. That is, summation of forces along x-axis equals 0 and summation of forces along y-axis is equal to 0. We have two equations only. No? Okay? So, we should choose a joint na may dalawang unknown bar force lang. Dalawa lang nakakabit na truss member. Okay? Kasi kapag tatlo na yung unknown natin, dalawa lang yung equations na mabubuo natin. So, wala tayong masosolve kapag ganon. So, we need to choose a joint na dalawa lang yung unknown na nakakabit na member. Two unknown bar forces. So, saang joint yun in this particular problem? So, we have two possible joints for that. We have joint A. Ang unknown dyan is yung force along AE and then along AB. So, dalawa lang yan. And we can also choose joint D here. No? That is, ang unknown lang is yung DE, force DE along DE, and force DC. Okay? Hindi pwede sa B kasi tatlo yung unknown. Hindi rin pwede sa C kasi tatlo rin yung unknown. Hindi pwede sa A, mas lalong hindi pwede sa E kasi apat yung unknown dyan. So, dalawa lang option natin. We can start at A or D. So, kaya sabi ko kanina, Pwedeng hindi mo na isolve yung reaction dyan kasi you can start solving at D. Okay? So, yan. So, saan tayo mag-start? Maybe we can start at, where do we start? At A na lang. Okay. Alphabetical na lang ang gawin natin. Pwede rin. So, let's start at joint A. So, ang gagawin natin, we're going now to cut natin yan. Ganun lang natin. Palitan natin ng force yung na-cut na truss members natin. Okay, drawing lang natin. So, at joint A, mas maganda, yung suggestion ko lang naman, or you may or may not follow my suggestion, ano. But, para hindi kayo malito, i-assume na lang natin na pag nag-analyze tayo ng truss, i-assume natin na yung bar force member ay naka-tension. Okay? They are always in tension. Okay? So, i-assume natin na yung AE ay tension, AB ay tension. Which means that the equivalent arrow, yung force natin dito, ang arrow natin is directed away from the joint. So, kapag tension away from the joint, kapag compression towards the joint. So, i-assume natin na ito ay in tension. Okay? Naka-tension yan. Pag nagkamali tayo ng assumption, mag-negative lang naman yung result, which means na compression siya. Okay. Ayan. So, this is FAE, FAB. And don't forget, of course, to include yung reactions natin. At external force kung meron. Wala namang external force. Meron lang tayong reactions. Our AY is 2,100 newtons. And then our AX is... this should be our AX. 1,500 newtons. And then apply the conditions of equilibrium. Dalawa lang naman, no? So, summation of forces, wait lang. Summation of forces along x-axis is equal to 0. Upward forces positive, so very, very simple. So, FAE, upwards, minus 1 is equal to 0. Which means FAE is equal to 2,100 newtons in tension. Since positive yan, ibig sabihin, tama yung assumption natin na tension siya, ibig sabihin, tension nga siya. So, tension yan. Okay? And then, summation of forces, wait lang, kasya sa video camera. Okay, ito. Summation of forces along y-axis is equal to 0. I'm sorry, this should be forces to the right positive. Oh my goodness. This should be summation of forces along y is equal to 0. Sorry. Upward forces positive. So, summation of x na yung ilagay ko, pero yung forces na kinonsider ko ay yung vertical forces. So, sorry for that. Vertical forces, so y-axis dapat yan equal 0. So, FAE is equal to 2,100 newtons. Now, let's summate forces along x-axis. So, lahat ng horizontal forces. So, forces to the right, positive. Ano yung mga forces along horizontal axis? We have FAB directed to the right, so positive. Minus 1,500 newtons equals 0. So, FAB is equal to 1,500 newtons, which is in tension. Since tama yung assumption natin, positive yung result, at ang assumption natin ay tension, then tension na ito. Okay. We can check naman dito. Meron naman answer key dito sa taas. FAE, nasa yun? AE is Tama, naka-kilonewtons kasi. No? So 2.1 kilonewtons, so that's 2,100 newtons. And FAB, which is, where is AB here? Hindi na ilagay dun sa answer key. But FAB is equal to 1,500 newtons na tension yun. Hindi ko na-encode yun. Okay. Okay? Okay, so next, we can now proceed to saang joint naman tayo. So, saang joint ang gusto nating isunod? So, maybe we can proceed to joint, pwedeng joint B. Sa joint B, pwede na kasi alam na natin yung FAB. Kapag pumunta tayo sa joint B, ma-solve na natin yung BE and CB. Or maybe we can also go to joint D na lang muna. Pwede rin naman yun. Okay? So at joint D, ito na lang. So at joint D, drawing natin yung free body diagram sa may joint D. So this is joint D. So, yung mga forces at joint D, dalawa. Ay, tatlo pala kasi meron tayong external force. Again, i-assume natin na tension ulit. Don't forget to include yung external force natin na 600 newtons. Ayan. So, ito yung FDE. And this is FDC. Okay? Ayan. So, kailangan natin yung slope ng member DC. So, this is, given naman yung dimensions natin. Ito. So, given naman yung dimensions natin dyan. So, that is just equal to 2, 4, yeah, okay. Alam na natin yan. This is 2, 4, square root of 20 by Pythagorean theorem. Or you may simplify this one. Okay? So, yan na yan. Okay, so solve na natin. Again, apply natin ang conditions of equilibrium to solve for the unknown bar forces. Okay. So, summation of forces along X is equal to 0. Forces to the right, positive. Ano yung mga forces along X-axis? Meron yung FDC directed to the right. Okay. So, 2 over square root of 20 times FDC. Then, plus 600 equals 0. So, FDC is equal to negative 1341.641 newtons. Which means na kapag negative yan, ang assumption natin ay tension, pero negative. Ibig sabihin, wrong yung assumption natin. That means that FDC is in compression. So, i-correct na lang natin. This should be in compression. Okay, ilagay na lang natin letter C to signify that the member is in compression. Okay, next. Summation of forces along y-axis, upward forces positive. So, ano yung mga forces along the vertical axis? So, we have FDE na directed downwards. And then, meron din tayong FDC na directed downwards. Okay? Which is, so, minus vertical, 4 over square root of 20 times, don't forget na ilagay natin yung sign niya. Kasi nga, maling assumption natin, di ba? Negative yan. So, Dapat sana pa ganun. Okay. So this is now minus 1341.641. Okay. Wala na ang ibang forces. Okay, so we can now solve for FDE. FDE is equal to 1,200 newtons. Positive siya, ibig sabihin tension yung force sa may member DE. DE. Okay? So ito na. Okay, next. So, ilan pa ba ang kulang natin? Ilang members ba to? 1, 2, 3, 4, 5, 6, 7. Nasolve na natin yung 4. So, may 3 pa. Okay, next. Okay, next naman. Tayo ng ibang papel. Para makita pa rin natin yung figure. So, tapos tayo sa A, tapos na rin sa D. Next, maybe we can proceed to joint C. So, joint C, pwede na kasi nasolve na natin yung DC kanina, FDC. Okay. At joint C, dalawa na lang din yung unknown sa joint C. So, at joint C, drawing natin yung free body diagram at joint C. Ayan. So again, assume natin na tension yung mga members natin. So this is FDC. This is FCB. FCE. This is joint C. Okay. Yung slope natin, solve na kanina ito, yung slope natin. 2, 4 square root of 20. Okay. Right. So, ano yung FDC? FDC is negative 1341.641 newtons, yung FDC natin. Again, compression sana yung FDC. Pero pag binaliktad nyo yung arrow at ginanon nyo siya, gawin nyo na lang positive ito. Pero pag in-assume nyo pa rin na tension siya, dapat gawin yung negative yan. Okay, yung force natin. Pero sa ako kasi, lahat para hindi ako malito sa analysis, I don't know sa inyo kung anong gusto nyong mangyari. Okay. Pero para hindi malito sa analysis, i-assume na lang natin na tension. Kung compression yan, gawin nyo na lang negative yung ilalagay yung force. No? Yan. Pero kapag nalito kayo sa ganong setup, you can always change yung direction ng arrows sa totoo niyang direction. Okay? Okay. So at joint C, summation of forces along X is equal to 0. So, ano yung mga forces? Yung horizontal components nito. Tapos yung FCE. Okay. Okay. I think it would be better if we solve muna, summate muna ng forces along y-axis para masolve natin agad yung FCB. Equals 0. So, upward forces, positive. So, ano yung mga forces along the vertical direction? Ito, vertical components of these two forces. So, we have 4 over 20 times negative 1341.641. Okay. Minus, ito, Kasi downward siya. Yung vertical component niya, that is 4 over 20 times FCB equals 0. Ayan. So FCB is equal to negative 1341.641 newtons. Negative siya, ibig sabihin FCB is 1341.641 newtons na compression. Okay? Compression yan. Next, summation of forces along the x-axis is equal to 0. Ayan. So, ano yung mga horizontal forces natin? FCE. Okay. Tapos yung horizontal components nito. So, minus 2 over square root of 20. I'm sorry, this should be square root of 20 pala. Hindi ko nailagay yung square root nito. Ayan. 2 over square root of 20 times negative 1341.641 plus horizontal component nito 2 over square root of 20 FCB, which is negative 1341.641. Okay. Then wala na, so equate this one to 0. Okay? Equate this one to 0. So we can now solve for FCE here. FCE is equal, kasi magka-cancel yan, equal yan sa 0. Okay? Ayan. Okay, so that's how we solve for FCE. Ano ba yung kulang natin? And FCE tapos na, FCB tapos na rin. Meron pang isa, itong FBE. Sa FBE. Okay. So to solve for FBE, mag-proceed na lang kayo either sa joint E or sa joint B. Someone is calling me, so I'm gonna stop this video. Okay? And I think this is an emergency. We'll have another example na lang sa next video. So to finish this, proceed to joint E or joint B para ma-solve yung FE. Isa na lang naman na, so FEB. So the same procedure pa lang. Okay? So let's continue with another problem sa next video natin.